I think whenever we record using MS Teams, it's harder for students to watch the recorded video because you need to download, and sometimes there are errors in downloading and it will only be available for 20 days. So I will be using an external app to record the meeting, and then I will be uploading it in my Google Drive. I will be sharing you the link to my Google Drive. So when accessing the link for the Google Drive, you can only use your AUP email. Okay, so I will receive a notification that you are requesting to access the video from the Google Drive. You can't download that. You will be watching that online. Okay, so you must access it through your AUP email. Okay, so let us proceed with our review for today. So what you can see on the screen is an organic compound. So this is actually an expanded structural formula, or specifically a line angle formula. So in biochemistry, you would also see compounds like this one. Okay, so when we discuss the topics in biochemistry like the biomolecules like carbohydrates, proteins, nucleic acids, and lipids, you would also encounter this. But you first need to be familiar with the different functional groups. So when we study, or when you studied organic chemistry before, okay, it revolves around the element carbon. Carbon has a unique characteristic because it has 4 valence electrons. So I am just reviewing or refreshing you with the things that you have learned from your past chemistry subjects during your high school and senior high. Okay, so carbon has 4 valence electrons, meaning it has 4 electrons in its outermost shell, right? And so, what does it mean if it has 4 valence electrons? It only means that it can form 4 bonds. It can form 4 single bonds or multiple bonds. So the multiple bonds that it can form are 2 double bonds, or 1 single bond and a triple bond, or or all the 4 bonds, okay, or a single 4 bonds. Okay, so here, this is a line angle structure wherein each point, like this one, I hope you can see my pointer. So each point, yung angled point in here, represents a carbon atom. Okay, so now how do we identify functional groups? So you can download certain tables online which can guide you in determining or in identifying the different functional groups. Now let us look into this organic compound, and then the highlighted ones, those encircled, which represents a functional group. So for example, like this one, this is a ketone. So when you see a compound wherein you have a carbon and then another carbon, okay, so the ketone is actually an internal functional group. Okay, so the carbon to oxygen double bond is actually a ketone. Okay, and now let us move on to this one, the ether group. Okay, so when we say an ether group, what you would normally see, okay, what you would be seeing is a carbon and then an oxygen and another carbon. Okay, and this could be long chains of carbon. Okay, so never mind these spikes. So this is an ether group. Okay, another one would be so something related to ether, or something or a functional group which is somehow a derivative of an ether group is alcohol. I know we are all familiar with alcohol, right? Yan. So whenever we see an OH group or a hydroxy group attached to a carbon atom, it means that we have an alcohol as a functional group. So later when we discuss the different biomolecules in biochemistry, you will be seeing a lot of alcohol groups. Okay, another one is this nitro group. So the nitro group is represented by the N2O. So whenever you see an N2O attached to a carbon or to a molecule, so for example, this is a long chain of carbon, then this one, this N2O, is what we call a nitro group. Another one, okay, which we have in this organic molecule is the amide group. Okay, so an amide group is actually a derivative of a previous functional group which we call a carboxylic acid. So later you will see what a carboxylic acid looks like. So an amide group is, so if you will see on the screen or on this slide, we have here a nitrogen. It's actually nitrogen that is bonded in here. So we have actually a parent chain. So we call this a parent chain. So this is a long chain of carbon. So we have carbon in here. Okay. And then another, let's say this is that carbon. Okay. Where the oxygen is bonded through a double bond. And then we will have in here your nitrogen. Okay, and then it can be that another carbon will bond here, or sometimes it can just be carbon to oxygen double bond and then NH2, and then this is a long chain. So this is your amide. Okay, so in the nitrogen, it can either be two hydrogens that are bonded, or one hydrogen can be replaced with another carbon atom. So this is an amide group. Okay, now here is a summary of all the other functional groups in organic chemistry that we will also encounter later on in our discussion. So we have the simplest one, which is alkane. So I know that you are very familiar with alkanes. Okay, so when we say alkanes, we have kerosene, for example, those gasoline and diesel that we use in our automobile cars, and also in our LPG tanks, those are alkanes. Okay, so alkanes are characterized by a single bond only, and it is only composed of carbons and hydrogens. Now, when we take your alkane and we add one double bond, okay, like this one, then we now have an alkene. Now, when this double bond is replaced by a triple bond, a carbon-to-carbon triple bond, then we call that an alkyne. Okay? Now, if we have OH in your functional group, so here, what does R stand for? R stands for carbon or long chains of carbons. Okay? So when we have OH in our molecule or organic compound, we now have an alcohol. If oxygen is in between two carbons, we call that an ether. Okay, so epoxides, we will not encounter this that much. Okay, and then we have here the haloalkanes. So when we say haloalkanes, we say that haloalkanes are simply hydrocarbons or saturated hydrocarbons with single bonds only. So in haloalkane, we still have the alkane parent chain. However, one or two carbons or one or two hydrogens are replaced with a halogen. What are halogens? So if we will be looking at the periodic table, halogens are those elements belonging to group number 17 or group number 7A, which are your chlorine, iodine, fluorine. Okay, so these are your halogens. Okay, now we have here the aldehyde. Now, if you will notice, starting from this point, from aldehyde until acyl halide, what is their similarity? Okay, their similarity is that they have the carbon to oxygen double bond. So, those structures which have the carbon to oxygen double bond, we call them, this carbon, we call that the carbonyl carbon. So in aldehyde, okay, the functional group is the carbon to oxygen double bond and a hydrogen attached to the carbon. Okay, so aldehydes are actually terminal functional groups. So whenever you see an aldehyde molecule, you would always see the functional group either at the beginning of the molecule or at the other end of the molecule. Now, ketone, diba, in aldehyde, this one is a hydrogen. So in ketone, you will replace that with a carbon. Ketones are internal functional groups. Another one that we have are carboxylic acids. Okay, so carboxylic acids is characterized by this functional group, a carbon to oxygen double bond, and then attached to that same carbon is the OH group. So this is a carboxylic acid. We also have acid anhydrides. So for which are yung acid anhydride, ester, amides, and acyl halides are derivatives of carboxylic acid. So what happens is that for acid anhydride, this hydrogen in your OH group is replaced by another carbonyl carbon. Okay, another carbon to oxygen double bond, and then R, okay, is a carbon. Now for ester, okay, let's go back to carboxylic acid. Hydrogen will be replaced by an R group, and an R group is a carbon atom. It can either be one carbon atom or long chain of carbon atoms. So that is for ester. For amides, yung OH, the OH group is represented or is replaced by an NH2. Okay, and sometimes one or both of this hydrogen is also attached or replaced by a carbon atom. Now for acyl halides, okay, the OH group is replaced by a halogen. So whenever you see X, it means that it is a halogen, or the elements chlorine, fluorine, and iodine. Okay, now for amines, R, so remember R always represents carbon. So it can either be one carbon, two carbons, or long chain of carbons wherein the amino group is attached. So when we say amino group, that's the NH2. Now for nitriles, we have carbon bonded to nitrogen by a triple bond. Okay, so we also have imines, isocyanate, azo compounds, thiols, and arenes. Okay, so in a while, I will be